so our lesson today, it's called completing the square. We're moving on to the next method of solving quadratics, which is completing the square. But completing the square, completing the square has to do with factoring a little bit. So that's why, oh, you're fine, you're fine. So that's why I've got to ask you to do this factoring question up here. So, what we should notice there about that polynomial, that trinomial that we're gonna factor, is that the a is 1, so that means it's not gonna be very difficult. So we do our a times c, and what do we get when we do a times c? 16, let me, the marker get to work in here. So we got, we multiply, oh, I need a white marker. We multiply to get 16, but we gotta add to get -8. -4 and -4. So that would factor that way, right? And isn't that the same as that? If I've got the same quantity twice, can't I write it with the square? Okay, so that's what's gonna be involved in completing the square today. So that's what we're gonna have to try to work towards, okay? So I'm gonna clear that off. That was just easy schmeezy review, and then we're gonna go and actually use that same trinomial to solve a problem, excuse me. So, let's look, x squared minus 8x plus 16 is equal to 25. And the directions say to solve. So we're doing completing the square today. This will be another method, and it's the only way we're gonna do it, is completing the square. So, what, normally, when we were factoring or when we were doing square roots, we always wanted to set it equal to 0. But not when we're completing the square. It's okay to have a number over there when you're completing the square. So to start with, what we want to be able to do when we complete the square is get it to the problems that we were doing Tuesday, where we could just undo the square and take the square root. So if I can get this side to have a big squared on it, then I can complete the square. So we would try to get this into one of these, which is what we just did on the bell ringer, right? We said a times c is 16, the factors of 16 that add to -8 are -4, -4, so I can have x minus 4 squared, right? So see, factoring is still gonna play a little bit of a role in this. Okay, now we're trying to solve, and we solved this equation on Tuesday. That whole left side was being squared, so how do we undo that squared?
Square root it.
Square root it, so x minus 4 will equal the positive or negative square root of 25. Now started you off with a nice easy one, because 25 is a perfect square, right? What times itself is 25?
5.
So we gotta remember that that can be a positive 5 or a negative 5, because we're gonna get two distinct answers here. Because to finish solving for x, we would add our 4 to both sides. So you have to add your 4 to the positive 5, and you have to add your 4 to the negative 5. So your two answers would be 9 and -1. You alright?
Yeah.
Don't choke on me over there. I have to come stomp on your chest.
I'd like to see that.
I got my party on boots on today.
That hurt.
Okay, so what made that all work nice and easy, because there wasn't any difficult math there, right? So what made that all work nice and easy is that this trinomial factored into something pretty like that. So that's gonna work when our C is a good C.
At this time, we need sophomores, last name starting M through R. Sophomores, last name starting M through R to the multi for pictures. Thank you.
Christian.
I don't see how we got the parentheses.
A times C 16, factors of 16 that add to -8, or -4 and -4. So writing x minus 4 twice is the same thing,
Oh,
yeah. Good. Okay, so what I was saying is what made that all work nice and pretty like that, that you're able to factor it with the same thing twice, it has a lot to do with your C. You're gonna, when we're doing completing the square, you're gonna hear me talking about a good C or a bad C. So when we're trying to get our good C, what we're gonna do, there's gonna be a little formula and you need to write it in your notes for this lesson. To get our good C, we're gonna take our B and half it and then square it. Okay, so let's check that on the problem that we just did so you can see what I'm talking about. Problem that we just did. So our C is 16, right?
Do
So-
we need to write this down?
Yeah, so according to this formula up here, to find a good C, 16 would equal our B, which is -8, divided by 2, and squared. So is that a true statement there? Okay, let's do the math and work it and see. -8 divided by 2 is -4. -4 squared means -4 times -4, which is 16. So there's gonna be times, and we're gonna do some today, where our C is not good, and we'll have to do some figuring to get a good C. Alright, let's work a couple of those that are set up easy and ready to go before we get to a harder one. X squared plus 6x plus 9 is equal to 36, and the directions say to solve. Now, after next week, well, actually I think it's Monday, when we'll learn the last method of solving, then it's up to you. You can decide which one works best for you, and you got try to figure out hints about if it's already like ready for one. And so I would see something like this, and I would say that's already probably ready for completing the square, because I got a perfect square over here. So I see some perfect squares up there, so I'm thinking, oh, probably might be ready for completing the square. So let's check and see if this is a good C. If I take my B and half it and square it, does that give me that C? Okay, 6 divided by 2 is 3, 3 squared is 9. So that means to factor this, all I gotta do is take the square root and the square root. Okay, now that, I did that pretty quick, but you know that. Let's go through the baby steps. A times C is 9. What multiplies to make 9 but adds to make 6? 3 and 3. And so by putting that squared up there, I've written x plus 3 twice, haven't I? Just in disguise. So everybody good on that part? Okay, now to start solving, all we gotta do is undo that big squared. So we'll square root both sides. Can I skip you to that step? Is that okay? I just square rooted everything. Okay, now my 3 is being added to the x, so I gotta subtract it. But you need to subtract it from the positive 6 and the negative 6. How'd you do? New and crazy looking, but not too hard.
A little bit. It's the same amount of work, it's just some of it you do in your head instead of
Yeah.
writing it down.
Yeah. Okay. Let's step it up a step. X squared.
Attention students, last call for anyone who wants to purchase a ticket to the Harmony Grove Glen Rose game Friday night. Please come to the high school office.
Okay, so this one says x squared minus 12x plus 4 equals 0. And today, the only way we're doing these are by completing the square. If I were doing this one on my own, I would use the quadratic formula, but we haven't learned it yet. So this is a completing the square only day. So if I start checking to see if this will factor, because if we complete the square, we have to end up like that. So I start checking to see if this will do that. Take my b and half it. Half of negative 12 is negative 6. Square negative 6, I get 36, not 4. So this 4 is not a good C. So what we wanna do when we have a bad C like that is we wanna move it to the other side.
At this time, we need sophomores, last name starting S through Z. Sophomores, last name S through Z to the multi for pictures.
Make
Thank
sure
you.
smile pretty there, Zach. So we're gonna move, I wanted to keep mine down around my neck like that and he wouldn't let me. Yeah, he said, take your mask off, and I was like, I want it. He said, no. It's like, well, you grouch? What? I don't know why I couldn't do that.
Yeah, I'm wondering if mine's gonna be in there, cause like I took it off and just kinda held it like that.
Yeah, you won't be able to see it. Alright, so we got a bad C. I mean, 4 is a perfect square, but it doesn't work good with the negative 12. So we gotta move it out. So you just do that by subtracting it from both sides. So I got x squared minus 12x. I'm gonna leave a space here because I wanted to put something there. Is equal to negative 4. Alright, so we gotta have a good C to put in that blank space since we got rid of the 4. So we wrote down how to get a good C. You take your B and half it. Negative 12 divided by 2 is negative 6. And then you square it.
36.
36. So we gotta add 36 right there. I'm gonna add that in a new color. Now, I like to think I can do anything I want to, but I really can't. I gotta follow the same math rules that y'all do. So I can't just add a 36 because that changed the whole value of the equation. So what can I do to make that move legal?
Put 36 on that side.
Very good. Whatever you do on one side, you gotta do on the other side. Balance that out. So since I added 36 there, I gotta add 36 there. Okay, so now, what multiplies that gets me a 36, but adds to get me a negative 12? Negative 6 and negative 6, so my squared parentheses here would be x minus 6, right? You okay with that? And then when I add negative 4 and 36, that gets me 32. Now, not as friendly over there this time because 32 is not a perfect square. That just means we're going to have a radical in our answer, a square root in our answer. Let's undo the squared by square rooting. So x minus 6 is going to equal a positive or negative square root of 32. And I just told you that 32 is not a perfect square. It jumps from 25 to 36 on that right side of the chart you made the other day. So we got to go backwards and find the biggest perfect square that'll go evenly into 32. 25 is the first one underneath it. 25 won't go. 4 squared is 16. Would 16 go? 16 times 2, isn't it? So, x plus 6 is equal to, what's the, let me show all my work. I was fixing to skip a step, but I don't want to skip a step yet. And I wrote 12 on that crud. 16. 16 times 2. Okay, so what's the square root of 16 that gets to come out?
4.
So x minus 6 is equal to positive negative 4 square root of 2. So we're not going to get a nice normal looking answer like we have on the first couple. Our last step here, that 6 is being subtracted, so we're going to move that over. So we're just going to move a positive 6 over and put it in front of here, and that'll be it. Because we don't know the value of that to combine it. We're leaving an exact answer. So I'm just going to write x equals 6 plus or minus 4 square roots of 2, and that's it. Now, I showed y'all this last week, and it's correct. It's just not my preference. Some people like to add that 6 on the end. It's the same thing. You can, but I sometimes get confused on if it's supposed to be underneath the square root or not because I'm messy.
Isn't it, what is it? Real number? Oh, never mind. That's, no.
Imaginary.
What would get us an imaginary number in something like this? Because we're going to see it.
The negative version.
Right, we would have had a negative underneath with that 32. Good. And then, I know now what you're saying. You're thinking about the standard form, where the real one comes first, yes. So that would be, it's not the same thing, but this would be more like it, right? Good thing in there, Mr. Christian. Okay. next one will be kinda like the granddaddy of them all. 'Cause this will have to do a lot of, put it all together, do a lot of stuff. Alright, so we got 2x squared plus 8x plus 14 equals 0. Okay, so in all the three, have we done three? I don't know. In the few that we've done so far, what was the a in all of them?
0.
1,
Mm,
right? No number in front of the x squared, so I understood 1. So now we got a 2. So you're not gonna do completing the square when there's a 2 there, because you can't write that as a perfect square, right? Because x times x doesn't make 2x squared, right? So we gotta be able, if we're gonna do this completing the square, which we have to today, we gotta be able to get rid of that 2. So that seems difficult, but it's really not, because this is a friendly equation to get rid of the 2. What do I do to cancel, to get rid of that 2?
Combine that two.
At this time, we need any sophomore or any junior who has not had their picture made to come to the multi for their picture.
I don't have like
Any
terms.
junior, any sophomore to come to the multi pictures. Thank you.
I don't
divide
have,
by 2.
I don't have like terms, but they're all even, so I can just reduce it, divide it all by 2, right?
I was thinking two,
Do what?
I was thinking of two as a,
I got you. So this will be the same as x squared plus 4x plus 7, right? Just like saying 2/4 is the same as 1/2, right? Okay, so now we start looking to see if we can go with that, if we can come up with our perfect square with that. No, because there's nothing times 7 that, right? So I got a bad C. So we're gonna subtract that bad C from both sides. Leave me a space, because we're gonna have to find a good C. So what would a good C here be?
four.
Is he right? He said, Christian said 4.
Yeah, 4.
Okay, so half of your B, 4 divided by 2 is 2. Square it, 2 squared is 4. So he's right on the money, so we're gonna add 4. Whatever we do to one side, we gotta do to the other. Okay, now I can take this new trinomial that Christian helped us create and fill in my blanks down here. Because what multiplies to make 4, but adds to make 4?
2 and 2.
2 and 2, so that's the same as x plus 2 twice. And that's equal to -3. We're equal to a negative. What's our answer gonna have?
I.
Non-real and I. Very good. Okay, so let's undo the squared, square root. Now, lucky for us is that 3 can't break down anyway. So the only thing we can do is get rid of that negative by bringing an I out. So x plus 2 is equal to positive negative I square root of 3. And then you just got one step left. You need to move a positive 2 over. Oops. I'll get you, Holly, I'm sorry. What do you think about that? I try, I know y'all are still trying to figure me out, and you're gonna be trying to figure me out the entire year. I'm weird, I know. But I try to be honest with everything. And I'll tell you, when I was in Algebra 2, back when the dinosaurs roamed the earth and we learned all these same methods, I never understood this one. I don't know, I kinda like y'all, you're learning all these methods and you're like, oh, I don't like that one. And so I just kinda shoved it off and never understood it really. But then when I started teaching it, I was like, this isn't hard. So I just had a closed mind to it, and I said, well, I'm never gonna do that one because I can use a different method. And I made an A, it was fine. So this isn't your favorite way, it's okay. It doesn't have to be. But by the end of I think Monday, we're gonna learn the last way. By the end of Monday, you better be able to find a favorite way, because you're gonna have to solve these. So if it's not this, it's gonna have to be something. So it's not life or death, but there was no difficult math done there. So that is something that we can do. It's just getting the steps and making sure we got a good C and all that kind of stuff. Okay, I'm gonna go back and do an easier one and let you try it and see what happens. Does that sound like a plan? Alright.
Maybe we should do it really quick.
No, we shouldn't.
Well, if we're good at it, then no.
And it's funny,
Work
but
smarter, not harder.
I've had people say, well, completing the square is my favorite. I'm gonna complete the square. And I give them a high five and say, good job, you do that. Alright, so your C looks like it's good, cause 4 is a fun, perfect square. But that 4 doesn't jive with that 6. So get rid of your bad C, find a new good C, and go to town. Yes. Oh, Mr. Zach. Okay, so all I've done is got rid of my bad C and found a good C. So, did you get 9 for a good C? Good, 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 good. So now we know 3 times 3 gets me 9 and 3 plus 3 gets me 6, so I can write this as x plus 3 quantity squared. Okay, now just undo your squared. Okay, oh, forgot the square root symbol there, none shook. So 5 is not a perfect square, there's not one that'll go evenly into it, which we don't always like that, cause that doesn't give us a pretty answer, but it's less work, cause you don't have anything to do, so just move your 3 over. And you got it. You forgot to do what?
I forgot to put the negative in front of the 3.
Yeah.
So,
And when you cross that equal sign, you gotta do that. Now, can you go, this is what we're gonna end with, that's it for that problem, but I'm gonna take this that you came up with and go to the next page and use that, see if we can make an extension here. Can you take that and relate that to one of the types of quadratics that we talked about? Okay, what am I, we've looked at quadratics, and this has been a while, in standard form. We've looked at quadratics in vertex form. We've looked at quadratics in intercept.
that's the vertex one.
It is almost in vertex form.
Okay.
So what would you have to do to go from here to vertex form?
Set it to y.
What is this, other than the y equals, what is this missing to be in vertex form? We got, right, we got an understood A that's 1, x minus h, so our h would be -3, but we don't have a plus k. Where do you think that plus k could come from?
Five.
Move that 5 back over, right? So you could say x plus 3 squared minus 5, and now you've written that in vertex form. So completing the square, if you're ever told to write something in vertex form, you would do that by that process of completing the square. And that was just an extra bonus for you today, but that's something that's pretty handy to come in. Alright, so I know this, I normally try to give tests like every couple of weeks, but this, we've just had so much more to look at. This has been a longer unit, because we're at 4 weeks and we're still not taking a test yet, so it's been a lot longer, and I think also part of it is me getting adjusted to Wednesdays. Cause I mean, we're losing a whole day basically every week that we could be learning something new, cause they told us to try to just do review stuff on those days. So, anyway, we'll get it all worked out, but, so, where we are, we're going to practice this tomorrow, so I'll have an assignment for you to practice on this tomorrow, completing the square. Then Monday, we'll learn the quadratic formula, and that'll be the last method that we look at, and then you'll be able to choose your favorite. And what's good about the quadratic formula is it will always work no matter what.
No.
There are times when you can't complete the square. You can't find that perfect square trinomial. There are times when you can't factor. So quadratic formula is foolproof. It'll work all the time no matter what. That's why I saved that one for last, because then I knew you wouldn't listen to all these other ones. But it takes longer too, so you know, it's a trade-off. So anyway,
It's
we'll
a
look at,
compromise. on
yeah, we'll look at that one on Monday, and we'll sing a little song to help us remember it, and do that. And then after that, I think there's just one more lesson where we talk about some more graphs, and then we'll be getting ready for a test sometime into next week probably.
And just hit me that we are 4 weeks in
Yeah.
school.
Yep. Alright, well, good deal, Lucille. I think next week is when our